everyone, I'm Domingos and I'm also called a DMA and appreciate when I'm called DMA. Today we're going to solve an equation on a logarithm with different bases. It's often believed that it's impossible to solve equations in logarithm whereby the bases are different. Why? Because we know it is possible only to add or subtract two or more logarithms when the bases are equal. Because when the bases are equal, adding the two or more logarithms, you maintain the base, you keep the base, and then you multiply the arguments. But when it's subtraction, you have to keep the base and then you divide the arguments. But when it comes to this case, we can already notice that our bases are different. One log, the base is 2, and the other log, the base is 3. So how do we go about it? So we have to find a way whereby we have to transform the basis of the other log to be the same as the base of the other one. So how do we go about it? Because we know 2 is not 3. And also, if 3 was 4 or was a multiple, or like a number whereby we could write in the base of 2, that would have been easier. Let's say 3, if it was 4 here, we would say 4 is 2 to the power 2. If it was 8, it's 2 to the power 3. But in this case, it's totally opposite because 3 is a number whereby we can't literally write in the base of 2. Okay, so for that, let us let 3 to be equal to 2. Okay, when we say 3 to be equal to 2, mathematically that is wrong because 3 is not 2. So we can't let 3 to be 2. So we have to whether multiply this 2 by a variable to make our affirmation correct according to maths, or we can divide by a variable, or we can put an exponent, but it has to be a variable. So we have to implement a variable to say that 3 is 2 something. So since we are dealing with logs and we want this 3 to be a number in the base of 2, that means what we have to include, it can't be a denominator or a number multiplying, it has to be exponent. So that's why I'm gonna say 3 is equal to 2 to the power n. So it is not wrong to say that 3 is equal to 2 to the power n. Why? Because n is a number that we don't know, so makes sense we assuming that. So now what we do is going back to our equation and substitute the value of 3 to 2 by 2 to the power n. So substituting back, we will have log of x to the base 2 plus log of x to the base 2 to the power n equal to 2. Now, the base are almost the same, but they are not really the same. So logarithm property says when an exponent is when a number is an exponent of the base of the log, then this exponent can go at the back of this log multiplying, but goes inverted, so the inverse of this number. So that means we're going to have log of x to the base 2 plus, this is n, the inverse of n is 1 over n, log of x to the base 2 equal to 2. Now, this is log of x and this is log of x. They are the same, they are common. In maths, when you have 2 or more expression repeated, then you can factorize it. So let us factorize the common one, which is log to the log of x to the base 2 will be, when we factorize here, that means we will end up with 1. If I multiply, I go back. Plus, then when I factorize this expression, we'll only be left with 1 over n equal to 2. So now we have this log multiplying this expression equal to 2. I can calculate this. This expression is multiplying this log. In terms of maths, we know that if a number is multiplying in one side, we can send to the other side dividing. If it's adding, it can go to the other side subtracting. These are the simple rules that we know from maths. So now we're going to have log of x, isolating log of x to the base 2 will be equal to 2 over 1 plus 1 over n. That's what we have. We can solve here. We have n. We can find a common denominator, which is crossing and multiplying them. So we will have log of x to the base 2 to be equal to 2 over, the common denominator is n. Crossing and multiply, n times 1 is n plus 1 in the denominator times this 1 is 1 over the common denominator, which is n. Okay, now let's go further to see how we can solve about it. Now we have dividing this expression, and according to maths, when you have two numbers dividing each other, you multiply the first one by the inverse of the second one. So now what do? Now we're going to have log of x to the base 2 equal. Now if we check, we're going to have 2n over n plus 1. And then you could say why 2n? Because we multiply 2 by the inverse of the second expression, which is a fractionary number. Now we can isolate x. Now isolating x, according to log rules, we're going to have x will be equal to the base 2 to the power all these expressions, 2n over n plus 1. Well, we could say that this is our solution, but that would be wrong because we were not given any exercise with n included. N comes from us letting. We were not given, so we have to substitute back the value of n. So what is going to be the value of n then? Then we have to go back where we let. Where we let, just may put a star here. We said 3 is equal to 2 to the power n. To isolate n, that means I have to apply log on both sides. But it has to be with the base 2. Why? To eliminate with these two, since in logarithms, when the argument and the base are the same, it will always be 1. So isolating here, it is implied putting log to the base 2, and I will do the same on the right side, to the base 2. Then this n in the exponent of the argument can go at the back multiplying this log. So that implies that we're going to have n times log 2 to the base 2 equal to log 3 to the base 2. Log of 2 to the base 2 is 1. Then that implies that n is going to be log 3 to the base 2. That's the value of n. So we have to substitute the value of n back to the expression to see how x behaves. Now x is going to be equal to 2 to the power of this expression, which is 2 log of 3 to the base 2 over log of 3 to the base 2 plus 1. We could stop there, but that would be like lazy from us because we have to sort it out until we have a shortest form of x. Like it has to be simplified. So now how do we do then? We have 1 here and we have log of 3 to the base 2. Since we know in logarithm, we can only add two logs when they have the same base, then we have to transform this one in a log with the base 2. But we don't need to go far. We know that log of a number to the base, that number is always 1. So that means since here I have 2, I can say this one is log of 2 to the base 2. So we're going to have x is going to be equal to 2. Here will be 2 log of 3 to the base 2 over log of 3, sorry my 3 is a little bit ugly, plus log of 2 to the base 2. Because now log of 2 to the base 2 is 1. But looking at this 2 that is multiplying this log, we know when a number is multiplying a log, can go as an exponent of the argument. So that means we're going to have x to be equal to 2 to the power log of 3 squared to the base 2. This 2 comes from this 2 that is multiplying. And here they are adding each one. The base are 2 is the same. So I can multiply 3 times 2, which is 6. So I will have log of 6 to the base 2. Now x will be equal to 2 log of 9 to the base 2 over log of 6 to the base 2. Now we have a rule in maths. When it comes to log, when they are dividing each other and the base is the same, we apply the rule called change in base. So here is 2 and here is 2. That will be 2 log of 9 to the base 6. We can stop here. So our solution is 2 to the power log of 9 to the base 6. This is how a genius will solve this problem. It's tricky when the bases are not the same, but it's not impossible. From now on, you can solve by applying this rule, letting one number to be the other base number, but to the power something. Could be to the power nt. You can use any variable that you are more comfortable with. So this is how you solve, and we're done. Your homework now will be to substitute back where there is x to see if it verifies, and of course it will. So if you enjoy, leave your like, your comment, subscribe, and most importantly, share with your friends.